So more problem-solving examples, and this particular example involves something known as true bearings. The true bearings are used a lot with flying, orienteering, following maps, but it's a clockwise measure of the angle between a segment and north. So of B from A. So we have an airplane. Beautiful airplane flying around, do-do-do-do-do-do-do. I'm going to make the airplane go away. We don't need that anymore. We have this airplane starting at A. So there's point A. And we'll call straight up and down north. So there's our north. Airplane departs A and flies on a 143-degree course for 386 kilometers. So we got to draw a picture here. 386, so this would be 0 degrees. This would be 90 degrees. That would be 180 degrees. 143 is, I don't know, something like that. And so I'm going to label this 143. And this is 368. And right there, it's B. I'll call it B. Make it easy. Give it a name. Now, it's going to change a direction. And this next bearing is going to be measured from north again. Remember, that's north. Make this one orange. So there's 0 degrees. 90 degrees, 180 degrees. This would be 270 degrees. 233 is something, I don't know, like that. It's an estimation. It's not perfect. So this angle is 233 degrees and 472. Find the distance of C from A. So the plane is now at airport C. The distance would be this red distance. That's what we're looking for. So that is D. Before I do any problem solving here, before I try and find any numbers, I need to start filling in some more angles. There's a lot more information here that I need to get at. I'm hoping that this ends up being a right triangle. And I'm going to put an angle here. That angle is 37. How do I know that? Well, this north-south line is 180 degrees. This top part is 143. That leaves 37 here. These two norths are parallel, which means if this is 37, this also is 37. And if we do some subtraction from 360, 360 minus 233 minus 37 does happen to be 90 degrees. And that is ever so wonderful. So distance of C from A. Well, to do that, I hope that you can put this together and see, okay, to find D, it's going to be the Pythagorean theorem. So AC is equal to square root 368 squared plus 472 squared, and that ends up being approximately, it's not exact, it's approximately 598.5, and that would be measured in kilometers. Now the bearing of C from A. Okay, so remember these bearings are measured from true north. This problem, this question, is asking us, what's that bearing? If I was to start off at A and go to C, what would I set the compass in the airplane to? So it's going to be some angle in here, some angle right there, plus my 143. So this is a theta. I know it doesn't look like a theta, but it is theta. I'm using that as my variable. I need to find it. And since we have a right triangle, we can use SOHCAHTOA. So I have the side opposite and adjacent. So tangent theta is equal to 472 divided by 368. Remember, to find an angle, we use inverse tangent. So the inverse tangent of 472 over 368, this is approximately 52.06 degrees. But that's not theta. Theta is going to be 143, or it's not my bearing, I'm sorry, it is theta. It's 143 plus 52.06 for a grand total for our bearing of approximately 195 degrees.